All right, very good. Thank you. Hey, my name is Ravi Kuppuswamy. I'm essentially going to be here in this session along with my friends Anush and Vic. Okay, going to talk to you guys about how are we building agentic AI with AMD's EPYC CPU portfolio. Okay, we're going to talk a little bit about what is the latest and greatest in the EPYC portfolio. What is it that it helps from an agentic AI standpoint. And then Anush is going to come on, and he's going to explain how he's using this hardware along with the magic he does in software to come out with the best possible experience. And then we're going to have Vic, a partner, telling us how they're using it, okay, for their agentic AI deployment. With that, let's talk about what's fundamentally happening in today's data center. We are actually moving from what was a chatbot era to the agentic AI era. That requires a much different kind of data center than we've been dealing with in the past. What's the big difference? The fundamental difference is around there was one user essentially putting out a query, getting a response back. To now, there are multiple users spawning off many more agents that use the modern data center to go create an experience bar none. Well, today morning you heard Lisa show how everybody in the world is underestimating how fast agentic AI was growing. And we are going to show you today why that is the case. Why is it that every one of the folks out there felt that there is going to be growth, but vastly underestimated the amount of CPUs required to go make the modern data center work. Now, if you look at this, the pre-agentic infrastructure looks somewhat like a simple set of general-purpose servers along with GPU servers. GPU servers meaning the primary component in there is a GPU, although it does have a host CPU that kind of acts like a traffic cop in these GPU servers. That's how a pre-agentic infrastructure looked like. Now, if you were to look at the new data center, there's a whole new class of servers called the Agentic CPU server sandboxes. I'm going to come to that in a bit. But where I'm going with this is the entire agentic flow, when you dissect it into about 8 different blocks, we understood what each step of that agentic workflow requires what type of compute. And we found that several of those steps require this new class of what we call as agent CPU server sandboxes. Now, the general purpose servers don't go away. There are going to be more general purpose servers. The GPU servers don't go away either. There are going to be more GPU servers. But this new class of servers is growing faster and creating and spawning even more usages than what we all expected to be. So let's talk about what do each of these different types of server classes care about? What do they provide? Starting from the left, our general purpose CPU servers essentially cares about efficient performance. Now, usually we used to, if you've seen in past keynotes and stuff, we would normally talk about a server usually resides, a general purpose server usually resides in the data center for about 3 to 5 years. Okay? In that time frame, when you actually go replace those servers, and actually we have a metric that essentially says about 1,000 servers, Xeon class servers from about 5 years ago, can be replaced at approximately a 12-to-1 ratio. Okay, for every 12 servers, you can put 1. Now, that would be the metric for an efficient performance across a broad set of workloads. Now, these requires a broad CPU portfolio. It'll have balanced power and performance. And most importantly, a very good buying criteria these days is confidential compute. Okay, very, very important. Now, if you move one tick to the right, GPU servers have been there for the last, I want to say, at least 4 or 5 years. Okay? And in these servers, you want a different kind of a CPU. The one that keeps our GPUs efficiently utilized. It maximizes our perf per core, maximizes the utilization of our GPU, and most importantly, high bandwidth traffic between the CPU and the GPU. Now let's come to the most exciting and new class of these agent CPU server sandboxes. What are these? First and foremost, these servers essentially are running different kinds of tools. They are creating new kinds of scripts. They are working on tasks that allow us to communicate between these agents much better. So the more agents that you can generate from this class is going to give you a maximal amount of efficiency. So the number of concurrent agents is a very important metric. And you can map agents directly to CPU threads. So you want more agents per watt, you want more agents per dollar, and you want more agents per rack. So if you directly think about this, so if you have more cores in your CPU, you have more agents in your rack. If you have more cores in your CPU, you have more threads, and every thread acts like an agent. So wanted to go ahead and distinguish each of these different classes because clearly, if you had to take away one point out of this, you want to take away the fact that one size here definitely does not fit all. You want a portfolio that some of which act as general purpose servers, some of it act as a GPU host, and some of it certainly in this new class, an exciting class, act as agentic sandbox servers. Now, this is a slide that you saw a version of this in the morning with Lisa, but I want to translate what we just spoke about in the last slide to our latest Venice portfolio. If you look at this, we have our Venice SP7, which you can think of it as performance, leadership, core count, and all of this serves as both a great general purpose server, and the higher core count of this will serve as agent servers as well. And then you have Venice SP8, which is kind of optimized for the enterprise between performance and performance per dollar. And then you have Venice X for the highest HPC workloads that we have, the really high-performing stuff. And then we have Verano at the far right, which is truly a great host node. It has, because it also optimizes for system power that gives us the ability to go ahead and deliver the kind of communication bandwidth that you want between the CPU and GPU at a very optimal power point. So here you can see in one breath, what you really have is a broad portfolio of use cases serviced at all of the right optimization points using our latest Venice family. Now, how does this translate? It's not that we don't have good servers today. If you look on the left-hand side of this, you have Turin today, which is beating all of the competition in the different swim lanes, leading to Venice. So if you start from the top, we have our Turin essentially 8 to 192 cores in the general purpose category, that will now go from 8 to 256 cores. That same socket will also house a Venice X. It will also house SP8 for the enterprise. And then if you go look at the host node category, high-frequency 64-core Turin is one of the fastest ramping products today. That moves one step higher, where we go all the way from 64 to 96 cores and high frequency all the way to 5 gigahertz. And then in the new class, we have 192 cores, essentially meaning 384 threads, going all the way till 256 cores, where you have the densest platforms, and you're going to hear more about that, where agent density is so critical. We have all the way up to 512 threads on Venice. Let me give you a little bit around performance numbers to dissect this a little bit so you all understand how does this break down. What you have here in the left is essentially leadership, performance, and efficiency from a broad portfolio. The performance goes all the way 3.3x when you compare that against the competition. And then one of the most critical buying criteria today is our security features. You heard that earlier this morning, okay? All of the top people, but it was specifically called out by Anthropic and OpenAI and others that security is such a critical part of our portfolio. And what we have here is, all-round secure features as a part of the Venice portfolio. From a host node standpoint, we are providing 5 gigahertz with 96 cores on Venice. We're going to 16 channels. I told you that the CPU, GPU communication is extremely critical. We have 16 channels of DDR5. And then the I/O bandwidth goes from PCIe 5 to PCI Gen 6. Venice will be the first CPU to offer PCIe Gen 6. And then when we come down to agentic, you have 2.8x agents per watt. The same 256-core Venice, which nominally operates at 600 watts, will operate at 400 watts to maximize the number of agents per system watt. It will have 1.8x agents per dollar and greater than 2x in terms of agents per rack versus the competition. So it does not matter what the competition is, whether it be ARM AGI, Intel Xeon, or NVIDIA Vera, Venice beats them all across all metrics. Lisa actually had a picture of it, but she didn't go into very many specifics, but you're going to hear more from our partner. But I'm just going to introduce it by saying, when density matters and you need rack-level leadership for agentic AI, today rack-scale deployment is constrained in some sense by cooling, power, space. Venice provides substantially greater density and efficiency, about 1.9x more cores per rack, and 2.6x more cores per watt on the Supermicro system. So our partner today, Vic, will be here shortly to talk to you more about how they plan on using all of this agent density in their deployments. So EPYC leadership truly compounds into business value. It's enabling more agents and services with fewer racks, lower cost of ownership, which is the ultimate metric for deployment. With that, I'm going to ask Anush to come in here to say, how does he plan to use this fantastic Venice portfolio with the software stack that makes it usable for all of us. Hey, thank you. Here you go.
Thank you, Ravi. The next part of the story is about software. So I think a lot of you probably heard about ROCm on the GPUs. So what we want to talk about today is what are we doing on the CPUs? How are we going to make it easy for you to use the EPYC CPUs that we have and provide you a unified tool chain that can work across all of AMD's accelerator portfolios, CPUs, GPUs, and anything in between. So today we talked about, let's see if I can get the next one. Perfect. OK. So today we launched ROCm.ai. So ROCm.ai is an AI-driven development platform, right? And it focuses on skills so that it allows you to easily consume and program AMD GPUs. But now we're also bringing that for CPUs, right? So that we provide the same kind of capabilities to deploy and test and get the best performing get you the best performing EPYC deployments. So skills provides you an agentic interface, and then we also provide something called Hyperloom, which allows for automated performance tuning and tuning to specifications that you want, and you let agents run these performance models through the night. Like you're sleeping, and agents are churning away, making it much more performant, and then you wake up and you got a more performant model. If you looked at the keynote, you saw an example of Minimax getting like 36% from baseline, and that's done automatically with ROCm.ai. And then, of course, the core infrastructure still remains the same. We have the core SDKs, the frameworks, all of that. The key part of all of this is that we're now starting to bring that not just to Instinct, we're going to bring that to EPYC. And what this means is that of course, the programming model is different for CPUs and GPUs, but tool chains, your Clang compilers, all of this should start unifying and give you a simple way to consume and accelerate your workloads on CPUs as much as you do on GPUs. The ecosystem is an important part for us, right? Like what you do with Hugging Face, PyTorch, all of that, we are continuing to invest in that. And as you see, as we go forward, you'll see that it starts to blend how our software stack starts to permeate between GPUs and CPUs. And what this means is you get a raw CPU flavor that provides you the ability to program the CPUs and unlock the agentic workflows that Ravi was talking about. We're going to click a little bit more into the software stack for Agentic AI. Just like what Ravi mentioned, you have general purpose compute, you have the GPU servers. Whenever I see it, I call it ghost nodes because it's GPU host nodes. But you get the GPU host nodes where you can also run a lot of these agentic workloads, on like a Helios rack or even MI355 racks. And then you have these agent servers. So two important technologies that we are announcing today and as part of ROCm AI. One is called Apex, and Apex provides you the ability to prefetch based on agentic workloads. So this allows you to do tiered memory storage, not just for inference, it can also be for agentic tool calling. So you can think of this as, based on the workloads, based on some of the profiles that I've done, even for my own workloads, there is a lot of repetitive like file system accesses and bash calls that can be immensely accelerated if you just accelerate those tool calls. And so what we're doing is providing the ability for you to tier this into like NVMe. It can be NFS over RDMA based on how your configuration is. We bring that into the closest point of the into the hot cache, and then we can get immense amounts of performance boost in the agentic loops. And we'll share some performance on this in the next slide. The second part is something called Axis, and I'll tie this back to what Ravi had mentioned. We're not just like, it's not just silicon anymore, right? We're not just catching up on software. We are innovating in software now. So what we're doing is we're moving agentic sandboxes to the process level and tying it to what Ravi mentioned. If you get 256 threads or 256 cores and 512 threads based on your deployments, you're now starting to isolate agents at a process boundary. And for those of you who are familiar with things like Chrome sandboxes, et cetera, right? It's a lot more thoughtful, but the process boundary now is running at a process level. So which means if you get all of the amazing cores that Vic is going to talk about, you're now running at that many processes with the same level of security that you would get with a traditional heavyweight Docker-like container. But it's just like fine-grained, and it's around the process. And this works for file systems, networking, et cetera. Of course, I can't get into the details here because of the time, but after the session, if you're interested, happy to talk about Access and Apex. So let's talk about some performance numbers, because obviously it's going to be important. So Apex, we've seen about like 43% savings in return-turn TTFT for VLLM, right? And so this is it is a big boost in terms of TTFT for the first time to the first token. And this amount of like boost is just by adding Apex. So if we just can tier the memory right, you get an immense boost in performance. So that's part of ROCm.ai. And then the second part is Access. So we are seeing about like 96% savings in sandbox job execution latency. That is, again, it's amazing when you're running like thousands of agents. If you're getting a 96% savings, that is, it directly translates to how fast your agents are able to execute, because your tool calls are mostly your long pole in your coding agents, et cetera, right? So we accelerate that. And about 45% savings in memory required per sandbox. Again, this is, everyone knows why. I mean, the memory market's like a little bit crazy, so saving 45% is substantial for your agentic loops. So again, all of this with ROCm AI comes packaged, and you can just deploy on your EPYC Venice CPUs. So with that said, I do want to talk about MEXT too, AMD MEXT. We are super excited to welcome the MEXT team to AMD, and all of what they've been working on provides us about 1.34x performance per dollar on heavy workloads like Synopsys Primetime. And again, the focus areas are for traditional workloads that you can still get the benefits of something like MEXT, and it's doing an AI-based memory extension technology that allows you to run your traditional workloads with less system memory than what would normally be required. So the key takeaway from all of this is, again, as we go into the agentic era, we're not just providing you a tool chain. We want to innovate at every level of the stack, starting from the hardware, all of the great hardware that Ravi was talking about, but we are increasingly looking very, very, very deep into the stack at every level, whether it's memory prefetch, whether it is sandboxing, and if there's anything else that you think is important for how you're deploying to get the right outcomes for your deployments, please come let us know. We are, again, very receptive, and we take all the feedback and go grind on it and come back with solutions that help you. So with that said, I'm going to call Vic to come show us and talk to us about Supermicro. He's the Chief Business Officer of Supermicro. Welcome, Vic.
Thank you. Man, whenever I talk to both of these guys, I feel like, why am I on the stage? Because they know so much about these products and technology. And whenever I feel that I know enough about the technology, how it's evolving and all, they say, like, Vic, you know nothing, right? So the reason is this. I mean, in all seriousness, certainly appreciate this opportunity to be here. 6-7 months ago, when I talk about this whole agentic AI workloads, we just know it as a phrase, but at least not many of our customers were seriously talking or doing something about it. So that's very clear. And when we start looking at the products and technology, few months ago, when I was talking with AMD team, one of the things was asked is like, what is that you are going to do in terms of products that you are bringing, especially, you already have products with Turin, and as you bring the products with Venice, what is the product portfolio is going to look like? And I wasn't sure, like, why are we asking? Like, AMD typically doesn't ask, like, the configurations and whatnot. But there is a lot that was going behind the scene. And then they started talking to us, and that's where product portfolio started evolving. So when I take a look at what is happening right now, let's see if it clicks. All right, cool. So what AMD talks about is on the two ends of the spectrum. One is the CPUs, the GPUs, the network cards, and the security and everything that kind of brought in as the features and functionality at the firmware level. All that is great. And the other aspect of it, which Anush is talking about, is how you go in the higher up in the stack when it comes to applications and what the ecosystem need to develop and whatnot. What we at Supermicro do is to take the technology that is coming from AMD, all three things I mentioned. One is the CPU, second is the GPU, third is the network card, and network cards in this case. Put them together in a fashion that one can adopt it in their deployment. And when it comes to these AI platforms, GPU and CPU both, as a part of the equation, I'll get into that. What we realized is as things get deployed in a small data center, nobody cares. I mean, back in those days, if you put the system, you need to manage something, you go handle it directly yourself. But these systems, you're talking about hundreds or even thousands of systems at a time, you need to have a way to manage it. So what we have done is, fundamentally speaking, on the hardware level, Supermicro is a hardware company to start with. We have the broadest product portfolio that is based on AMD EPYC par none, right? And whether it's a single socket, multi-socket, multi-node, switch integrated and whatnot, we have all of those. When you put these systems in a rack and integrate and roll it into a data center, the first thing is we need to have a way to understand whether the systems are operating the way it's supposed to be. Means we need to understand if the thermal aspect of it is properly handled. If it's liquid-cooled systems, there is a CDU that needs to be looked at, whether that is operating properly or not. Be able to give the telemetry of what is happening within a rack, within a system, down to any level of detail. That is what we have developed as a super cloud composer. So this is the one that gives people to just go and deal with the bare metal before even it can be used for something. Then we said, well, this is good for people just going to go and look at if every part of the system is working fine or not. But we need to have a way to help people to go and deploy it. Because the larger ones, larger data centers, cloud service providers, that is their bread and butter. They know exactly what to do, how to do, and all that. But you can see that many of the customers that we are facing now are enterprise, neo-cloud, and other type of customers who may or may not know all the tools and who may or may not have all the resources internally to do all these things. This is where we need to kind of handhold or give some tools for them to use as an option. The second aspect of it is when you have all these systems, so that the tools such as SuperCloud Developer Console and a couple of other tools, what we are doing is, first phase is when you have all these hardware tools, the first thing is to be able to use Ansible or some other means to make it ready, and where you have installed the operating system, and you are able to create an environment where multi-tenancy, which is going to be a lot more common, and Anush kind of mentioned, Ravi mentioned about the security aspect of it. So we need to ensure that the network isolation and everything happens all the way to the CPU and whatnot. So that is going to be done as a part of the tool. Then you need to be able to have a way to install your, beyond the operating system. You need to be able to run Kubernetes, and you need to be able to create these clusters. You need to update the GPU firmware. You need to change whatever things that you want to do. That is yet another software piece. The final thing is going to be about using these systems and be able to do GPU as a service or something AI on demand, whichever it may be. So what we are trying to do is to make it easy for the systems, whether it's CPU or GPU, at scale, easy for people to adopt. And that way, when they buy these products, they know that they are able to get best use of whatever the available resources within that. And on top of it, the rest of it, you have open source software. AMD is famous for that. And you can have a ROCm and then go beyond that. So this is one thing that we are doing. And when I take a look at Helios, I was like, oh my God, this is such a beautiful system. I'm sure you have all seen this, right? It's big, it's massive and everything. I mean, coming from the hardware, it's like, oh my God, like finally the hardware looks sexy, right? It was, lost the charm and it was there. But I'm not going to talk about Helios because we have seen it, we have known it. What is going to be important and what we all have been talking about is the importance of CPU in this total, let's say solution, and why it is important. So multiple ways to look at it. Let's take an example of any kind of a GPU deployment. You have a bunch of GPUs, whether it's MI350, MI355, or Helios, whatnot. We all have that. That's the most expensive part. And that is what we want to be using the most optimal way. And for those who have seen the hardware, the power delivery is using a DC busbar, right? And the cooling of the system is liquid cooling. If you are deploying in a data center, the data center basically need to be prepped to handle these GPU platforms. Then, I'm first talking about the physical aspect of it. Now, if I have to run every one of these GPU systems will also have the pre-compute, and you have a lot of CPU-centric workloads that you need to have. For that, you need to have systems, right? When you roll in this, the typical servers that many of use is going to be a standard rack mount systems with air-cooled, with standard power supplies that is being connected. You have PDUs coming with 63 amps or 100 amps type of current and whatnot. But you're talking about a DC bus bar. So we kind of started looking at in order to make it easy for people to adopt this in that environment, we need to have same kind of an environment. So the systems were designed to have the same DC bus bar type of power delivery for that, liquid cooling, the second aspect of it. And third and most important thing, which both the presenters have alluded to, with respect to Agentic AI workloads, the need for the CPU is more than ever before. So GPUs are great at doing fantastic things. They have massive parallelism. They go and do the matrix multiplications, and you talk about standard AGI workloads, it will do a fantastic job. But the Agentic AI workloads, as you know, the reasoning, the queries, and all the agents that it needs to spawn off. A simple request is fine, but some of these complex requests can actually spawn off like hundreds or even thousands of agents further. These agents need to have access to the memory, the CPUs, and whatnot. This is where the maximum core count becomes very, very important. Second is, we have limited power, and the other part of it, within a rack, the power need to be utilized to the best. This is where the second aspect of it is coming in, where we are trying to pack as many cores as possible to enable queries coming from not from 1, 10, or 100, thousands of or tens of thousands of people using Agentic AI workloads and each spawning multiple ones, eventually running into millions of queries and whatnot. In order to do that, you need to have a very, very balanced architecture. Of course, CPU being at the core here, we're talking about 256 cores and per CPU and double the amount of threads. So effectively, I do not know where I am, but let's see. If I take a look at the systems here, you are able to get about 43,000 plus cores in a functional approach. What does it mean? So each of these racks basically have all this compute along with power shelves and standard switches along with it. So we are able to pack 43,000 cores in this one. This is phenomenal. And what also it does is it fits into the same power profile as other systems that are using it. And in terms of how these things are connected, we can have multiple options. You can use Pollara, you can use the other Ethernet as a fabric. But ultimately, as the requests coming in, there's level of concurrency, but at the same time, the level of parallelism that is required to handle all of this. In order to do that, we are able to pack all of them in a small form factor in a rack. So in the last 2 minutes, whatever I'm talking about, all I'm basically trying to say is the rack core density is extremely important. It needs to be easily deployed. And it is also important to have a balanced architecture in terms of how many cores to how much of memory, and how these things are to be connected, and how many of these systems or racks need to be rolled in order for us to have a very balanced architecture for agentic AI workloads. What is also happening is many of these queries are extremely latency bound. So, if you are using this infrastructure very efficiently, 60 to 90% of these queries, which are heavily latency sensitive, we are going to optimize that. That is the reason CPU is more important than ever before in any kind of AI deployments. That's what actually excited me when I started working with AMD team, because this is not something where Supermicro suddenly says, like, oh, let's pack and all that. So the requirement came, and Anush was asking, like, hey, how many maximum cores that you can put in this system? I said, like, okay, we can do this. Why is it important? Because he was talking about, let me run through the numbers and see how the performance scales and whatnot. All the numbers that are happening there, luckily there is no pop quiz, so I don't have to remember all the numbers. But so much of work has been done on that one in order to give numbers that are very predictable. Because at the end of the day, in a small sandbox environment, doing some benchmarks and having good results is great, but you need to actually prove that in the field. In order to do that, you need to have a way to scale across a larger ones, right? So that's on that. Oh, sorry. So this particular one, what we are talking about is the systems need to be scaled in an environment where we are going to talk about a compute and the GPUs and the storage, the networking, all these things need to come together. Cooling is becoming a very, very important factor in that as well. So I'm talking about cooling and all that because I'm a hardware guy, right? Because you have limited amount of power. And within that limited amount of power in a data center, you want to use that power as much to the infrastructure as possible in order to get the best bang for the buck. Because ultimately, no matter how you look at it, the token expense has to come down. And by running things more efficiently, the software piece is going to be an extremely important thing, but the hardware balance is equally important in terms of getting it to that level. So on the platform design side, we take a look at whether it's going to be the air-cooled one or the liquid-cooled one. What is the kind of rack density that we require? What kind of mixed workloads that people are going to run? Because we're all talking about agentic AI, but at the same time, there are several workloads. The standard GPU deployment that are happening, they have tremendous amount of compute already for all the pre-compute and pre-fill stages. That's all happening already. But this in additional thing on top of it. So we need to have which kind of platforms we use and whatnot. And then we are also balancing with storage. So what we are trying to do is, KV cache is something that is mentioned in this. So you need to have the right amount of cache and memory and cores and whatnot within a CPU. And then you need to have the fast memory. I don't know if you have noticed, but Venice, you're talking about two different types of memories. The standard RDIMM going up to like 8,000 and the MRDIMM going to 12.8 gigs, right? The amount of throughput that you get out of it is tremendous, right? And also it has PCI Express Gen 6, so a lot of bandwidth to get the stuff in and out. And now, when you're adding these systems into your GPU environment, you can see how the balance of that needs to happen. Beyond that, when you need storage, that is where the storage performance comes into picture. What are we doing with them? Working with AMD and also with our partners in terms of the storage, we are bringing high-performance flash arrays and making sure that the whole solution is going to come together. This is not about a single, it's not about a CPU, it's not about a GPU, it's not network. The whole thing needs to be holistically looked at as a system-wise or a data center level type of problem for people trying to solve these problems, right? So this is where we are looking at the system design, also the data center design, and when you are deploying in a data center, how the overall thing need to be looked at and how the telemetry need to be considered. These are all the things that we are looking at. And then what happens is that in a typical scenario, every enterprise, when they are deploying AI, why should they deploy? Just because I am telling, just because AMD or somebody is telling? That's not how it is. Companies basically are there to make money. And they need to basically run things more efficiently. In order to do that, they need to adopt AI in a way where it's going to have a business improvement. And this is where scaling from a small sandbox level to a massive scale running to millions and millions of agents is extremely important. So this is where having an ability to do all these runs and everything and provide people, this is the blueprint that you can take it and run with it, that becomes extremely important. That's something that we are working closely with AMD in order for us to give predictable performance and predictable experience for customers. And when you take a look at that, another part is like, it's not just the number of cores. So who cares? I mean, whether you have 192 cores or 256 cores, it is about the business value again. What we are trying to do is when you have these many cores, and each core is performing in certain way, and threads, AMD point of view is like 2 threads per core. Now we are talking about, in this kind of flex twin where you have 86,000 plus a number of threads that can be done. So when it is being deployed in an enterprise world, people are going to look at like, well, I can have these many users running these many different workloads, able to use these many agents, and it's going to help me with my business in this way. So that's ultimately a CFO discussion. So this is what we are trying to see. When you're adopting it, you are actually going to benefit from it. I know it sounds, let's say, simple, but it's very complex. Every enterprise that is chasing the adoption of agentic AI, the one and only problem that they have is, if they do that, if they adopt it, is it going to help them or hurt them? When I say help and hurt, it's not just about getting the work done quick and all. Of course it does. But the second part of it, at what expense? If you heard Lisa's presentation this morning, one of the things that bringing the cost lower per token is extremely important, and bringing the efficiencies higher. And the only way for that is to basically for us to look at and how to bring that. And when many, many agents are going to be working, what is that we can do on a hardware level in order for them to do that? Another part of it is, when these things are getting deployed, predictability is important. I mean, how quickly we can roll in. Why? Because if you can see all the flash and the memory prices and everything, the way that's increasing, when you are trying to adopt it, we want to bring that solution as quickly as possible. So one is a procurement, second is a deployment, and what is that we can do that. So together with that, when we talk about orchestration, bringing the security, and working with the partner ecosystem to bring the right value, that is the kind of a goal. What exactly are we doing with AMD in this case, right? So when I take a look at it, alignment is extremely important. We are working with AMD, going back to 2016 timeframe when the first Naples CPU was announced, and 2017 June timeframe it was actually launched. We had the platforms there. AMD hardware has always been amazing. It's the ecosystem that took time to develop. What Anush's team is doing right now is to actually help all this ROCm software stack, optimizing on that. And thanks to many of you that are actually part of it, that's also helping on that. So one is the strategic alignment as to what we are doing and why we are doing and how we are doing. Second is the co-engineering. Why co-engineering is important? Because if I did not know certain workloads need to be run, or certain density requirements are there, or certain type of scale at which it needs to run, I won't be able to develop, right? So we work together to make sure the platforms are coming at the right time with the right configuration for our customers to adopt it. And when we are talking about deploying, another part of it is the deployments are never simple. Things do go wrong and things will go wrong. In that case, how are we able to solve the customer problem? And AMD has been absolute best partner in terms of putting resources and making sure these things are going to be supported and customers are going to be successful as they adopt these platforms. And this is a continuous collaboration. It's not like a one-time thing. So we've been doing it. So I think it's about like 5th generation or 6th generation. So we're talking about Naples, Rome, Milan, Genoa, Bergamo. Now we are talking about Turin and Venice. So I lost the count of it. And the reason it's important is because this is a trust that we have developed over a period of time. And if you take a look at the AMD's market share in the CPU, I heard it as 46% and counting. And that's because the products are relevant for what customers are using. And in this specific case, what we are trying to do is to make it very relevant for agentic AI workloads. And by providing a solution that is going to be work the best, whether it's air-cooled or liquid-cooled environment, small enterprise or a large-scale hyperscaler, No matter whatever the size and shape and form that problem statement may come, we are having the right solution and we have the right resources to help in getting that adopted. So that's all I wanted to say on this one. It's an excellent partnership, and I appreciate all the time and help that's given by AMD to make it happen for us. Thank you.
Hey, thank you, Rick. Thank you. I'm just going to wrap it up here in just a minute, but you saw both Anush and Vic say, how are they bringing the hardware to life with the software? And then how does, in this particular case, Supermicro use it to provide value to our customers? What I wanted to quickly show here is, it's not alone Supermicro. There are multiple OEM vendors across the board who are using this for Agentic AI. And you can see everything from, this is something that Lisa showed as well. Every one of the top OEM vendors, along with partners across the ecosystem, have all put out dense racks. They're all building and innovating on top of Venice platform to bring the best for our customers. Okay, and in that experience, and you can see that there's everybody from HP, Supermicro, Dell, Lenovo, and I couldn't fit all of the other folks on this slide. Okay, and then this is something that was there on Turin, and if you go to Venice, the numbers only increase. They're even more on Venice now, and you can see all of the core counts out there are phenomenal in terms of providing the value for Agentic AI. So what I wanted to do is, hey, end this thing by saying the world's best server CPU portfolio, EPYC is the true and clear choice for building out on Agentic era, okay? And then we've shown this for the different types of workloads, whether it be general purpose, host, or the Agentic sandbox. So we are really, really excited to work with the broader ecosystem in bringing this to market.